ಹಲೋ ಎವ್ರಿವನ್. ಇವತ್ತಿನ ಕ್ಲಾಸ್ನಲ್ಲಿ ನಾವು ಕರೆಂಟ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಚಾಪ್ಟರ್ನ ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟ್ ಆಫ್ ಸಿಲೆಬಸ್ನ ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಸೊ ಯಾರ್ಯಾರು ನಮ್ಮ ಚಾನಲ್ನ ಹೊಸದಾಗಿ ನೋಡ್ತಾ ಇದ್ದೀರಾ ದಯವಿಟ್ಟು ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿಕೊಡ್ರಿ. ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ ಜೊತೆಗೆ ಈ ವಿಡಿಯೋನ ಶೇರ್ ಮಾಡಿಕೊಂಡು ನಿಮ್ಗೆ ಈ ಟಾಪಿಕ್ ನಾನು ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಮಾಡೋದು ಇಷ್ಟ ಆತಂತಂದ್ರೆ ಈ ವಿಡಿಯೋನ ದಯವಿಟ್ಟು ಲೈಕ್ ಮಾಡಿರಿ. ಓಕೆ, so coming to the syllabus, next part is the temperature dependence on resistivity. So in case of metallic conductor, in case of metallic conductor, the resistivity for a metallic conductor is of a small range of temperature. It is given by the expression rho T is equal to rho naught into 1 plus alpha into T minus T naught. By this expression it is given the resistivity of a metallic conductor is given by rho T is equal to rho naught into 1 plus alpha into T minus T naught, where rho T is nothing but rho T antandre it is nothing but resistivity. Rho antandre resistivity. So rho T antandre resistivity at temperature value T. Okay, next rho naught antandre it is also resistivity at reference temperature T naught, reference temperature T naught. Okay, so alpha antandre enu, alpha is nothing but it is the temperature coefficient of resistivity, which is a constant. Okay, so this is how the metallic conductor resistivity of the metallic conductor is given by this expression. Okay, when temperature increases, the resistivity of metallic conductor always increases. Okay, and the dimensions of temperature, dimension of alpha, that is temperature coefficient alpha, is per temperature, that is k raised to minus 1. Okay, then for metals alpha is always having positive value, and for semiconductors alpha will always be equal to negative. Alpha value will always be negative. Okay, so for alloys like nichrome, manganese and constantan, they show very weak dependence. For alloys such as constantan, nichrome, manganese, these show very weak dependence on the resistivity with temperature. This is why these materials, that is the alloys are used, or you can say the alloys are used in wire bound standard resistors. Why these are used in wire bound standard resistors? Because their resistance values, alloys are having the resistance values which would change very little with the temperature, with a change in temperature. That is why these are used in wire bound standard resistors. Okay, now let us study the graphical representation of how these are some of the points which can be asked for 1 mark, either in your CET you may say, or for final exams. These will be asked for final exams. Say for example, what is the temperature coefficient value for metals? It will be always positive. Whether whether the semiconductors are having the temperature coefficient value positive or negative. What is the temperature coefficient value? Means alpha is the temperature coefficient value. What is the value of temperature coefficient for semiconductors? It is always negative. Okay. How does the resistivity of metallic conductor increases with the temperature? Means it will be directly proportional. If temperature increases, then the resistivity also increases. Okay. So why alloys are used in wire bound standard resistors? Because these alloys, they are having resistance values. Because let me write it here. Because these alloys have values which would change very little with the temperature. That is why these are used in wire bound resistors. Okay. So next we are going to study the graphical representation to show how this resistivity of a metallic conductor increases linearly with the temperature. For this condition, we are going to draw the graphical representation. Right. So before explaining the graphical representation, once again I want to remind everyone that please subscribe to my channel, like the video, and then share it with your friends. Okay. So this is the graphical representation to show how resistivity of metallic conductor varies with the temperature. It always increases linearly with the temperature. Means as the temperature increases, resistivity also increases. Okay. Then second graphical representation is the variation of resistivity of semiconductor with the temperature. Means the resistivity of the semiconductor, it decreases with the increase in temperature. Okay. This is for the semiconductors and this is for the metallic conductor. This graphical representation is for the semiconductors and this is for the metallic conductor with respect to the temperatures. Okay. So these graphical representations, they can be asked either in your CET, they will be given 4 diagrams. Okay. Out of those you have to choose the correct graph which shows the variation of resistivity with the temperature for the semiconductors or the metallic conductors. This is how you will be asked.